Hello friends and welcome to the basic course of engineering circuit analysis. Now in the previous videos we have gone through the basic concepts that are required to understand engineering circuit analysis. So in this new section which is called basic laws, we will be learning some important laws which you have to understand in increasing your knowledge on engineering circuit analysis. So we'll start with the basic definition of a network and circuits. Then we'll go for the definition of nodes, paths, loops and branches. Then we will go to the most important law, which is Ohm's law. Then we'll move on to the Kirchhoff's law. The Kirchhoff's law are considered to be one of the most fundamental concepts that you have learned to understand circuit analysis techniques. So you are having KCL and you are having KVL, which is Kirchhoff's current law and Kirchhoff's voltage law respectively. Now, there are some very important passive sign conventions that you have to understand for KCL and KVL that also we'll be covering. And for each and every concept, that is from the definition of nodes, paths, loops and branches to Ohm's law to the Kirchhoff's laws, you will be doing a lot of numericals to understand each concept properly. So in this video, we will start with the definition of network and circuits. So let's start with the video. So the basic definition of a network, or when do you get a network? You get a network when two or more circuit elements, so let me tell it once again, when two or more circuit elements are connected together, we get a network. Okay, so basically a network is an interconnection of two or more circuit elements. So I'll just put that here. So network is an interconnection of two or more circuit elements. So for example, let me just give you an example of a network here. So I'm having two elements here like this. Okay, so if I connect them together, this becomes a network. So let me call this as network 1. So network 1. For example, I'm having multiple elements. I can draw something like this. Okay, so I am here having roughly 1, 2, 3, 4 elements and these are all connected. So this is also called a network. A network is basically an interconnection of two or more circuit elements. Now I am always drawing a resistor because a resistor is just easier to draw. But you see in the definition, it is only mentioning circuit element. So it can be anything. It can be a resistor, it can be an inductor, it can be a capacitor, it can be a voltage source, it can be a current source, it can be a dependent source, anything. Any two circuit elements, two or more circuit elements connected together, we call it as a network. Okay. Now let's take one example here. So this is also an example of a network that you can see here. So it has three circuit elements. So let us call it as 1, 2 and 3. So you can see that this is the point of interconnection of all these three networks. So that is the basic idea. Now you can see that this is like an open network, right? This is an open thing. Whenever you are having a closed path, okay, so the idea is that when a network has a closed path, it becomes a circuit, something like this. So whenever a network has a closed path, it becomes a circuit. Now if you observe these elements here, so I'll just call them as R1, R2, R3 and V1. Now observe this R2, R3 and V1 here. So let me just take a different color. So this is R2. Yeah, this is R2, R3, V1 and R3. So this particular structure you notice. So this is like a closed network, right? This is a closed network. So whenever a network has a closed path, it becomes a circuit. So circuit in this case, the circuit is R2, R3 and V1. That is the combination of R2, R3 and V1 becomes a circuit. So basically a network is a broad term. However, when a network has a closed path, it becomes a circuit. Okay, so if you have a broad spectrum like this, so this is your network. A circuit, sorry for that. So this is your network. This whole circle is your network. A circuit is a subset of that set. Okay, so all circuits are networks, but all networks are not circuits. So for example, if you see the previous slide here, this is a network. This is a network. It does not have a closed path. Okay, but if you see this particular path here, this R2, R3 and V1, it is having a closed path. Therefore, it becomes a circuit. Okay, so all circuits are networks, but all networks are not circuits. That is a very important point. So I am putting that here. All circuits are networks. All circuits are networks, but all networks are not circuits. This is a very important point. So I hope you understood the point we are trying to discuss today. In the next video, we will see the definition of nodes, paths, loops, and branches.